we need to prove the following. So let's begin from the left hand side. On the left hand side, we have in the numerator 2 sine theta cosine theta minus cosine theta. So if we take cosine theta as the common factor, so this will now be multiplied to 2 times sine theta minus 1. Now in the denominator, we have 1 minus cosine squared theta. So if we want to combine 1 minus cosine squared theta, that will be sine squared theta. So here we are using the fact that we have the standard identities, and sine squared theta plus cosine squared theta equals to 1. So we have replaced 1 minus cosine squared theta with sine squared theta. Now we are left with minus sine theta, and we also have another sine squared theta, which will get to the sine squared theta to give us 2 times sine squared theta. This gives us cosine of theta divided by 2 times sine of theta minus 1. Then in the denominator, we're going to take sine theta as the common factor from each of the two terms. So we have sine theta multiplied to 2 times sine theta minus 1. So 2 sine theta minus 1 gets factored out, and we are left with the ratio cosine over sine, which is the cotangent function. So we have cotangent of theta, and that is the expression on the right hand side. Hence, we have successfully shown that the left hand side is equals to the right hand side. Hence, proved.